This is Simple Harmonic Motion A2 Module 4 January 08. Question 4. The total energy of a particle oscillating with amplitude and frequency is given by E equals 2 pi squared mx naught squared f squared. Write down the SI base units of energy E. So energy E is kg m squared s to the minus 2. And if you need to, you could put your well, we'll just check that actually. So that's equal to kg. X naught is an amplitude, which is meters squared, and F is in seconds to the minus 1, and it's squared, so that's S to the minus 2. Write down the SI base units of the following quantities: kg, m, and S to the minus 1. And hence confirm, so I've actually gone a step ahead of myself here, hence confirm that they are equal to each other. So kg m squared s to the minus 2, and then is equal to, so you've got kg m squared and then s to the minus 1 all squared, which gives you kg m squared s to the minus 2. So the next part of the question, the way in which the displacement x of a body of a damped pendulum varies with time t is shown in figure 4.1. Note that figure 4.1 shows the frequency of the motion is constant, i.e. that the time period stays the same. The mass of the bob is constant. Make use of equation 4.1, and I'll just write it down again here. E is equal to 2 pi squared m x naught squared f squared. Make use to deduce the way in which the total energy of the pendulum depends on its amplitude x naught. So if you look at the equation, there's the total energy and there's the amplitude. So E is proportional to x naught squared. On figure 4.2, sketch a graph showing how the total energy depends on the time. And you can see there that the total energy of the system is decreasing because the amplitude is decreasing, and therefore it's going to be a downward curve which will eventually get to 0 when the displacement ends up at 0. Just shown like that. Last part. Explain how the principle of conservation of energy applies to the way in which the total time E of the pendulum bob varies with time. So energy is lost, or appears to be lost, due to friction between the air and the pendulum. This is because work is done against friction. And the end result then is that heat is transferred to the surroundings. And eventually all the energy of the bob will be transferred as heat to the surroundings. So there's a mark for discussing energy lost, mark about work done against friction, and then heat being transferred to the surroundings.